Ever wondered how your devices connect to the internet? It all starts with an IP address. What's the difference between IPv4 and IPv6? Why do some IPs start with 192 while others look like random letters and numbers? In this video, you'll discover the secret behind IP addresses and why they matter, how to read, understand, and assign IPs like a pro, the key to mastering subnet masks, DHCP, and private versus public IPs. Don't get lost in the network. Watch now and take control of your connections. In this course, we're going to talk about the IP address. An IP address is a numeric address. It makes it possible to identify a computer or any equipment on the network. Each device must have a unique IP address in order to communicate on the network. The IP address consists of two parts: onto the network address and the host address. The IP also exists in two versions, IPv4 and IPv6. Here's an example of an IP address in version 4. IPv4 is the version that is most used today, but not for very long, because it will eventually be replaced by IPv6. IPv4 is a 32-bit numeric address, which is written in 4 digits, separated by periods, and each group of numbers is called byte. This is a number that can range from 0 to 2555. Version 4 of the IP can produce more than 4 billion addresses. The people who invented the internet thought that this number of addresses would be more than enough. But today, we are running out of IPv4 addresses, and that's why IPv6 is being deployed. The main difference between IPv4 and IPv6 is the length of the address. IPv4 is a 32-bit numeric address, while IPv6 is a 128-bit hexadecimal address. Now, here's an example of an IPv6 address. Hexadecimal uses both numbers and alphabets in the address. With this, it is possible to have an unlimited number of IPv6 addresses. Because to saturate the system, more than 667 million billion devices connected to the internet would have to be placed on every square millimeter of the Earth's surface. So, we will have no problem communicating with Mars. As we have seen, the IP address consists of two parts, an eastern part for the network, and the other for the host. Now, to find out which part belongs to the network or the host, well, that's where the subnet mask comes into play. A subnet mask is a number that resembles an IP address. It allows you to know how many bits of the IP address are used for the network by hiding the network part of the IP address. IP calculation. For example, here we have the network address 192.168.0.1 with the subnet mask 255.55.2555.0. The first 3 bytes of the mask are therefore 255. Now, if we change the subnet mask to binary, then the first 3 bytes will only be 1 because the set of numbers in a byte is equal to 255, and we do the same with the IP address. So, we have our IP address and its subnet mask in binary format. To know which part of the IP address is part of the network, well, you have to base yourself on your subnet mask. The network portion of the IP address corresponds to all the digits 1 of the subnet mask. The number 1 indicates the position of the IP address that defines the network. So, we're going to cross out all the digits in the IP address that align with the 1 in the subnet mask. This way, we can clearly see that the first 3 bytes are the network part and the rest is the host part. We will now talk about the different classes that exist. The following is a representation of the default subnet masks for Class A, B, and C IP addresses. You can see different parts of the network and hosts based on classes. It is important for the exam to memorize these 3 classes by default. IP addresses are assigned in bulk to different organizations. And it was IANA that determined these classes. In all, there are actually 5 classes, but only the first 3 are to be known for the CompTIA certification. We can differentiate these different classes very simply by looking at the first byte. For example, the first byte of Class A ranges from 0 to 126, 128 to 191 for Class B, and from 192 to 223 for the C class. You'll notice that the 127 is missing. Well, that's because it's a network reserved for testing, which is called loopback. Now we're going to talk about the difference between public and private IP addresses. Public IP addresses are publicly recorded on the internet. This means that if you have a public IP address, then you can move freely on the internet. While private IP addresses are not publicly recorded, so you cannot access the internet with a private IP address. For example, imagine you have a small business and you need 5 public IP addresses for your employees to access the internet. If you contact your internet service provider to ask for 5 public IPs, well, it may take up a big part of your small business's budget. So that's where private IP addresses come in. With private IP addressing, you can assign 5 private IP addresses to your employees and use only 1 public IP address to exit to the internet. This not only saves money, but also prevents the waste of public IP addresses. Because remember, we are in need of IPv4 addresses, and that's why we are gradually switching to IPv6. This is why IP addresses of our different classes have been privatized to remain internal to the company. On the diagram, we can see the different IP ranges, which have been made private, on the 3 classes, A, B, and C. In this way, several companies will be able to use the same private addressing plan, provided that they do not circulate on the internet to avoid duplication. Anyway, since private addresses are not routable, well, they won't go very far. Before we finish the course, we're going to talk about the different methods to get assigned an IP address. Each computer on the network must have an IP address in order to communicate. There are 2 ways to assign an IP address to a computer. Either by using a dynamic IP or with a static IP. The dynamic IP is obtained automatically using a DHCP Dynamic Host Configuration Protocol server. DHCP is a protocol that allows hosts to be configured dynamically. The DHCP server therefore allows you to automatically assign an IP address to a computer, and he can even, in addition, assign the subnet mask, the default gateway, and a DNS server. For example, if I open the TCP IP properties of my laptop's network card, which runs on Windows, you can see that it is configured to receive an IP address automatically. And it's my internet box that acts as a DHCP server. By activating this option, my PC will send an IP request to the DHCP server. The DHCP server will then assign me an IP address from its IP pool. This type of addressing, i.e. the dynamic method, is very common because it greatly facilitates network management. The other method is static IP, which is a manual assignment of the IP. Here, it is the user, or the network admin, who will have to configure an IP on the computer. There is therefore no need for a DHCP server. This type of addressing is permanent, because unlike dynamic addressing, where the IP address can change automatically, a static IP address only changes if it is the user or network admin who intervenes on the PC. We have seen that when the computer is configured to automatically obtain a dynamic IP address, it obtains it from the DHCP server. But what if this computer fails to communicate with the DHCP server, even though it is configured to automatic? Well, in this case, the computer will assign itself its own IP address, like a grown-up, except that this address will be on the 169.254.0.0 network. This is called an APIPA, Automatic Private Internet Protocol Addressing Address. The term APIPA translates to automatic assignment of private IP addresses. In fact, it's so that computers that are part of this same network can always communicate with each other if they don't get a dynamic or static IP address. And if the DHCP server becomes available again, well, the computer will change its IP to that of DHCP.